Hi everyone, let's do the extra level. So I asked you if you completed all of the tasks before or above, you can actually, you would like to plot all the PDFs and then indicate some statistics on them, like median or standard deviation. But the plot would be overcrowded, right? Because that's what we did here, but now we are getting 15 of them, and it's hard to display it so it's not too busy. You can't do it one on top of each other because then you will lose information. If you do 3 by 5, that's 15 plots, or I don't know, 5 in each subplot, 5 on in one plot. It is a lot of information, so there is a way, instead of representing in this way, this is also very useful because you can see that it's a good fit. But what you can do is you can use some other ways of visualizing, and I indicated here to Google box and whiskers plot. So if you open a new tab, so box plot pie plot, you can look it up. Oh, this is obsolete. So let's just use a new documentation on Matplotlib, and it gives you this, so it shows you how it looks. So you're going to get this box and whiskers. So you see box and then you have the whiskers here. The whiskers are here basically the first and the box is from the first or the third quartile, and then you have the whiskers are indicated here, Q1 minus 1.5 IQR. You can read what that is. It's just statistics. And then you have also indicated the outliers. The way you do it should be very easy, very straightforward, and because we have 15 PDFs, right? And I said, like, before we do for 15, let's just start with one. Just do the first PDF or a data set, and then see how that's going to look. So it is going to be something like box plot is equal to PLT box plot, and then the only argument you need, the first argument is just your data, right? And then here all of the other arguments are, well, you can go through them, you can see if you want a notch there or not, and so on. But let's just do the simple one. So you have data and our PDF one. You just run it, and there you go, you get your box plot. So the orange line is the median, the box is the first or third quartile, and then you have the outliers and so on. You can convince yourself why this is oriented this way and not this way, but I'm not going to tell you that. You can look it up or try to understand it. Okay, now we made this for one plot, but now let's do it for all 5, for the first 5 and then the next 5 and so on. Now the thing is how to do this. You can do maybe the first 5 on one plot, but then you would need a legend, and I would actually, it's a workaround here. Something it's not really working with boxplot. The legend is not really communicating well with the boxplot for some reason, because of the way the thing is read. I think the data needs to be transposed because, as I said, you see here is flipped. So the way I would do it, just to show you quickly, I would basically do 5 subplots and then do the titles of each subplot. So let's do it quickly. So we just say fig axis is equal to PLT subplots, and then we can first set how many. So I want 1 row with 5 columns, and then our fig size can be something like 5. It's a 15.5, maybe 15.5. Let's see if that's going to be okay. Oh, and then another argument, because they're all going to share the same y-axis, I would say they can share, so we can say share y is equal to true. And then also, let's just see how this looks. Okay, what we can do is you can adjust the width between the plots as we did before. So PLT subplots adjust, and then you say W space is equal 0. Now they're squeezed together. Always be careful, because now you can see here there's an overlap, but I don't think that there's going to be an overlap, because here you say you only have one tick, so I think we should be fine. And now what we're going to do is iterate over our data. So we need the columns and the data set. So we again need two loops. So it's going to be for I, j, in, zip it, and then the first thing is going to be columns over columns, the first 5, and then the other thing is going to be in the range from 0 to the length of our first 5 columns. First 5 columns, something like this. And then we can say, let's just see what would I print I. Yeah, PDF 1, 2, and 3, and 4, 5. Okay, this is our thing. And then print J, just to see J 0.13. Okay, that's good. So X is, so if our X is, J is going to 0, 1, 2, 3, 4, 5. So then we have the X is J dot box plot. And then data with columns, right? Because I is exactly the columns names. And then we also want the title. So X is again with X is 0, 1, 2, 3, 4, 5. Oh, 0, 1, 2, 3, 4, sorry. Dot set title. Notice the syntax is a little bit different because we're not doing PLT dot title, but set title is for axis when you're doing subplots. And then the title, well, is just going to be the calls list. How did we call it? Calls list. And it's going over the first 5 and then looping over the first 5, right? Something like this. There we go. So now you can see that all of them, as you can see, we are increasing the spread. So the median or the mean is the same for all 5, but the spread, or now that translates into quartiles, is growing as you go from PDF 1 to PDF 5. Now think about how you can extend this for other PDFs, PDFs 10 to 15. So this should be the way you can do it. If you want, you can look up how you can do three subplots. So the first subplot can have PDFs 1 to 5, second subplot 6 to 11, and so on, 6 to 10. And the third one has the last 5 PDFs. But then you would need to do the legends to indicate the PDFs, and then you have to think about how you can basically transpose the data and why there is a problem with the box plot, the way the box plot is plotting the data and the way your data is arranged, so the shapes will not match. As I said, it is a bit of workaround, but you can do it. And that is it for this. Now another thing that is remaining is to do the level hell, and I'm going to show you how to make a web app, so stay tuned for that. Hope you enjoyed, and see you all in the class. Bye bye.